It's a Tuesday morning in 2003, Toronto. A government office building, fluorescent lights, the hum of a ventilation system. A man is sitting at his desk, turning a scratch-off lottery ticket over in his hands. He hasn't scratched it yet. He's just looking at it. His name is Mohan Srivastava. He's a geological statistician. His job involves analyzing ore samples, estimating mineral deposits, calculating probabilities buried inside incomplete data. He is, in every measurable sense, the wrong man to hand a lottery ticket to for fun. He scratches it. He wins $3. A small win, meaningless. But on his walk back from cashing it in, something happens. A thought, a question, an itch that he cannot explain and cannot ignore. He wonders, briefly, whether he could figure out the winning tickets before scratching them. He decides to go home and find out. What happened next would expose one of the most embarrassing structural flaws in the history of the lottery industry. Mohan Srivastava, a man who wasn't even trying to get rich, cracked a government-issued scratch-off lottery system using nothing but a pencil, a notebook, and 45 minutes of his own time. He discovered the flaw, reported it to the authorities, and walked away. He never cashed in. He never exploited it. He just wanted to know if he was right. And he was. This is the story of Mohan Srivastava, the geologist who accidentally broke the lottery and then handed the key back to the people who built the lock. Mohan Srivastava was born in India and grew up inside a world defined by numbers. Not the cold, abstract numbers of a classroom, but the working, practical numbers of the physical world. The kind of numbers that tell you how much gold is buried under a mountain you've never been to. The kind that tell you, with some degree of confidence, what you'll find if you dig in a certain place at a certain depth. Numbers that describe reality. Numbers with consequences. He studied statistics, then geostatistics, the specific application of statistical science to geological data. It's a field where the central challenge is always the same. You have incomplete information, and you need to make meaningful predictions about the thing you can't see. You look at what's on the surface. You model what's underneath. You estimate. You calculate confidence intervals. You work with probability the way a carpenter works with wood, as a material, something to be shaped into something useful. He moved to Canada and settled in Toronto, where he worked as a geological statistician for a consulting firm. By 2003, he had been doing this work for years. He had a comfortable life, a good salary. He was not a man who needed to cheat at anything. He was not even particularly interested in gambling. The scratch-off ticket he bought that February morning. The details of the exact date are not public record, but Srivastava has confirmed it was a winter morning in 2003, was a novelty. A coworker had bought him one as a small gift, or he'd picked one up on a whim. The accounts vary slightly. What does not vary is what happened next. He won $3. He walked to the lottery retailer to cash in his $3 prize, and on the walk back, standing in the cold Toronto air, he had the thought that would change everything. He started wondering how the lottery actually worked. How did scratch-off tickets get made? Somebody had to design them. Somebody had to decide which ones won and which ones lost. Somebody had to ensure that the overall payout rate matched what the lottery corporation had promised, that a certain percentage of tickets would win, and that only a certain number of jackpot tickets would be in circulation. That somebody was a mathematician, a programmer, someone who designed an algorithm. And Mohan Srivastava knew, from decades of working with probability, that truly random systems are vanishingly rare. The moment you introduce a human-designed algorithm, you introduce structure. And structure, if you look hard enough, has patterns. He didn't go home and start immediately. He filed it away, the way you file away an idle thought. But the thought came back, and came back again. About a week later, on a Saturday afternoon, he sat down with a tic-tac-toe scratch-off ticket, one of the most popular formats sold by the Ontario Lottery and Gaming Corporation at the time, and he started looking at it, really looking at it. The game was simple on its surface. The ticket displayed a series of tic-tac-toe grids, and your numbers hidden beneath the scratch-off coating, needed to appear in a winning line. Standard stuff. But the ticket also showed, visible without scratching anything, a collection of numbers printed around the edge of the card. 8 groups of numbers, exposed, already there for anyone to read. Those visible numbers were supposed to be decorative. They were supposed to look like part of the game without actually meaning anything. They were meant to give the card a sense of density, of complexity, to make the player feel engaged, surrounded by numbers, all before they'd scratched a single panel. That was the intention. But Srivastava noticed something. He looked at the visible numbers, then he looked at the grids. He started trying to figure out whether there was a relationship between what was visible and what was hidden underneath the scratch-off coding. And there was. He didn't have a computer. He didn't have a database. He had his training in geostatistics, his understanding of how random number generation works in practice, and a pencil. The key insight was this. In order to make the game feel varied and rich, the designers had to populate both the visible numbers and the hidden numbers using the same underlying pool. The numbers on the outside of the card and the numbers beneath the scratch-off surface had to share a common source, because the algorithm was generating all of them together. And this meant that the visible numbers gave you statistical information about the hidden numbers. Specifically, Srivastava noticed that the numbers printed visibly on the ticket appeared a certain number of times. Some numbers appeared once, some appeared twice, some appeared 3 times. And he noticed that the numbers appearing exactly 3 times in the visible field were almost always represented in the hidden winning grid as well. He developed a simple rule. He called it the singleton rule, though he didn't use that exact language publicly at first. Look at the numbers visible on the outside of the ticket. Find the ones that appear only once, the singletons. If those singletons populate a tic-tac-toe row in the hidden grid, the ticket is likely a winner. He tested his theory. He went to a lottery retailer and spent a few minutes examining tickets without buying them. He wasn't scratching them, he was just reading the numbers on the outside, the decorative numbers, the ones everyone ignored, and sorting the tickets into 2 piles in his mind, likely winners, likely losers. Then he bought a selection of tickets he'd predicted would win. He was right about 9 out of 10 of them. He went back. He ran the test again. He varied his sample. He bought tickets he predicted would lose, just to confirm his methodology. He tried to break his own theory. He couldn't. By Srivastava's own account, the whole process, from the initial insight to the confirmed proof, took about 45 minutes of his actual analytical time. Not 45 hours, not 45 days, 45 minutes. He had cracked it. Now, here's the moment where this story diverges from every other story in this genre. Every other story about a man who found a loophole in a gambling system ends one way. He exploits it. He extracts as much money as possible. He builds a system. He brings in partners. He scales up. He gets greedy. He gets caught. He loses everything. Mohan Srivastava did not do any of that. He sat with his discovery for a few days. He thought about it carefully. And he did the math. Not the dramatic, exciting math of how much he could make, but the practical, boring math of whether it was even worth it. He calculated that he could identify winning tickets at a rate high enough to guarantee profit. But the profit per hour would have been, by his own estimate, around $600 a day. Working full-time at the lottery counter, examining tickets without purchasing them, selecting winners. $600 a day. His salary as a geological statistician was more than that. He said later that the moment he realized the exploitation wasn't even economically rational, given his opportunity cost, he lost interest in the money angle entirely. He had found the crack in the system. That was the interesting part. The exploitation would just be a job. A tedious, potentially illegal job that paid worse than his actual job. But there was something else, something that mattered more to him. If he had found this flaw in 45 minutes, other people could find it too. People with more time than he had. People with less to lose. People who would not stop at $600 a day. He thought about the people who spent their grocery money on scratch-off tickets, who told themselves the game was purely random, that everyone had an equal chance. Those people deserved to know the truth. He contacted the Ontario Lottery and Gaming Corporation. He wrote them a letter. He explained what he had found. He included his methodology. He included examples. He offered to demonstrate. He was not aggressive about it. He was not demanding. He was a man who had found something broken and wanted it fixed. For a moment, nothing happened. He sent a follow-up, then he called. He eventually got through to someone senior enough to understand what he was saying. He went into their offices. He sat down with their security team and their game designers, and he walked them through it step by step. He showed them the visible numbers. He showed them the hidden numbers. He showed them the pattern. He let them try to disprove it. They couldn't. The Ontario Lottery and Gaming Corporation pulled the tic-tac-toe game from sale. They investigated how broadly the flaw existed across their other games. They redesigned their ticket generation algorithms, and they thanked Mohan Srivastava for bringing it to their attention. They did not pay him for the discovery. He did not ask. And for a few years, that was essentially the whole story. A quiet, professional act of civic responsibility. A man found a flaw, reported it, and the flaw was fixed. It happened. It was over. But in 2011, a journalist named Jonah Lehrer published a piece in Wired magazine that brought Srivastava's story to the attention of the world. And the world had questions, not just about Mohan Srivastava's specific discovery, but about something larger, something that the story implied without quite saying outright. If one geologist with a pencil could crack a government lottery game in 45 minutes, what did that mean for all the other games? For all the other scratch-off tickets in every other state and province and country? Were they all vulnerable? Had anyone else already found the cracks and kept quiet about it? These were not paranoid questions. They were reasonable ones. And when other investigators started looking, really looking, the answers were uncomfortable. Lottery scratch-off tickets, it turned out, were not a solved problem. They were a recurring problem, a structural one. The core challenge is this: creating genuine randomness is extraordinarily difficult, especially at scale. A lottery corporation needs to print millions of tickets. Some percentage of those tickets must win. The winning tickets must be distributed unpredictably enough that no one can game the system. But they also need to know, in advance, exactly how many jackpot tickets are in each print run, because they have to budget for the payouts. They know the answers before the tickets are sold. This is the paradox at the heart of the scratch-off business. The lottery has to know which tickets win. The player is supposed to not be able to know. The entire enterprise depends on the information asymmetry being unbreakable. But every time you design an algorithm to generate that asymmetry, you introduce structure, and structure is the enemy of true randomness. Srivastava understood this immediately, because it was essentially his day job. Geostatistics is the science of inferring hidden truths from visible proxies. The lottery's visible numbers were, to him, exactly like the rock samples he used to model an ore deposit. Incomplete information, but not zero information. The question was whether the lottery industry broadly had recognized the problem he had identified. The answer, according to the investigations triggered by the Wired article, was not consistently. In the years following Srivastava's disclosure, researchers at MIT and other institutions began examining the structural integrity of lottery ticket generation more carefully. What they found was a landscape of uneven quality. Some lotteries, particularly the larger, more sophisticated ones, had invested heavily in cryptographically robust random number generation. Others had not. Others were operating with algorithms that dated back to the 1980s and 90s, designed in an era before lottery fraud was a serious academic concern. And there were winners, a lot of winners, in patterns that statisticians found difficult to explain away. A lottery retailer in Ontario, this was a separate discovery not related to Srivastava's specific game, was found to have won prizes from scratch-off tickets at a rate statistically impossible to achieve through pure luck. The Ontario Lottery and Gaming Corporation commissioned an investigation. The investigation found that a network of lottery retailers had been exploiting a system of their own, one that did not require cracking any algorithm at all, but simply involved checking tickets for customers and pocketing winners while claiming the ticket had lost. That scandal was enormous in Canada. Hundreds of millions of dollars in prize money may have been misdirected. It triggered criminal charges, industry reform, and a fundamental restructuring of how lottery retailers handled customer tickets. Srivastava watched all of this from the outside. He was not involved. He had not cracked that particular problem. But the OLG scandal illustrated something his own discovery had already suggested. The lottery system, in multiple different ways, was not as airtight as the public had been led to believe. He started talking more publicly about what he had found. He gave interviews, he appeared in documentaries. He was careful, precise, not inflammatory. He didn't claim the entire lottery was corrupt. He described a specific technical flaw in a specific game that he had identified and reported. He was also careful to note that the game had been pulled and the flaw corrected, but the implication hung in the air. He was asked more than once whether he thought other lottery games, in Canada and the United States and Europe, might contain similar structural flaws. His answer was always the same. He didn't know for certain, but he thought it was possible. He thought the structural incentives of the lottery industry, the need to produce tickets at scale, cheaply, quickly, with predictable payout rates, created conditions in which genuine randomness was genuinely hard to achieve. He thought the 45-minute flaw was probably not unique. He was right. In 2010, a statistician named Srivastava, a coincidence of surnames, this is a different person, published an academic paper analyzing the statistical properties of a different state lottery game in the American Midwest. The paper identified anomalies in the distribution of numbers on scratch-off tickets consistent with a non-random generation algorithm. The paper was peer-reviewed. It was published. It was largely ignored by the lottery operators in question. Around the same time, a computer scientist named Robert Barnhart began cataloging what he called statistical lottery anomalies, instances where the frequency of winning tickets in a given geographic area or among a given class of ticket purchasers deviated significantly from what pure chance would predict. His dataset covered 6 states over a 10-year period. The anomalies were numerous. Some were explainable by fraud of the retailer type, people checking tickets and pocketing winners. Others were not explainable by that mechanism. A subset of the anomalies pointed, at least circumstantially, towards something that looked like Srivastava's discovery: a sophisticated player who could identify winning tickets before purchase. Whether anyone was actively exploiting such a flaw in those cases was never proved. The lottery operators argued the anomalies were within acceptable statistical variance. Independent researchers disagreed. What is not in dispute is that by 2012, Mohan Srivastava's story had become a reference point, almost a founding document, in a growing academic and journalistic conversation about the integrity of the scratch-off lottery industry. He had not set out to start that conversation. He had set out to satisfy his own curiosity, confirm his suspicion, and then do the right thing with what he found. But the story had a life of its own now. The Wired article had been read by millions of people. It had been republished and excerpted and linked to thousands of times. Lottery commissions in multiple countries had been asked by journalists whether their games were vulnerable to the type of analysis Srivastava had performed. Most said no. A few launched reviews. The most significant consequence was the academic and security community's renewed attention to the problem of pseudo-random number generation in lottery systems. A working group was established, loosely affiliated, not formally constituted, of cryptographers, statisticians, and lottery security consultants who began publishing recommendations for lottery ticket generation that were specifically designed to prevent the kind of structural leakage Srivastava had identified. The core recommendation was simple, in principle. The visible numbers on a scratch-off ticket, the numbers that appear in the decorative surrounding field, should be generated completely independently from the numbers beneath the scratch-off coating. Not from the same pool, not at the same stage of the algorithm, independently, so that no mathematical relationship could exist between what is visible and what is hidden. It sounds obvious in retrospect. It sounds like something that should have been obvious from the beginning, and perhaps it was, to the very best lottery security designers. But as Srivastava's case demonstrated, it was not universally practiced. It had not been practiced in at least one major lottery's product at the time he bought his $3 winning ticket. The industry changed. Not overnight, not uniformly, but it changed. Some lotteries went further than just separating the visible and hidden number pools. They moved toward what cryptographers call verifiable randomness, systems in which the process of generating ticket outcomes is so transparent and cryptographically robust that it would be theoretically impossible to find a Srivastava-style structural leak. Others contracted with independent security firms to audit their algorithms before print runs. Whether every lottery in the world has addressed this vulnerability is unknown. What is known is that the vulnerability existed, that it was found by a man who wasn't looking for it, and that the man who found it chose to fix the system rather than exploit it. There is something in that choice worth sitting with. Mohan Srivastava could have spent years quietly extracting money from the lottery. He had done the math. He had decided it wasn't worth it. But beyond the economics, he had another reason. He said it himself in multiple interviews. He had children. He thought about what he would tell them if they asked how he had made his money. He thought about the people on the other side of the counter, the people who couldn't afford to lose what they were spending on scratch-off tickets, but who kept buying them because they believed in the randomness of the game. He said he found the idea of exploiting them, even indirectly, distasteful. This is not a word you hear often in gambling stories. Distasteful, not dangerous, not illegal necessarily, not worth the risk, just distasteful. Wrong. The kind of wrong that doesn't need a law attached to it to feel like wrong. By 2015, Srivastava had largely returned to his regular life. He still worked as a geological statistician. He still applied the tools of probability and inference to the physical world, to rock and mineral and ore. He had become a minor celebrity in the world of lottery security and statistics, someone whose story was cited in textbooks and conference presentations and investigative journalism. He had given a handful of talks. He had been pleasant and precise and unhurried about all of it. He was asked in one interview whether he ever regretted not cashing in on his discovery before reporting it. He said no. He thought for a moment. Then he said something that stuck. He said the lottery flaw was the least interesting thing about his story. The interesting thing to him was the question of why the flaw existed at all. Why had the people who designed the game not seen what he had seen? They were smart. They were mathematicians. They had tools he didn't have. They had resources, computers, test environments, peer review within their own organizations. And yet they had produced a system with a 45-minute crack in it. His answer was that they were thinking about the game from the inside. They were thinking about payout rates and print runs and customer experience. They were not thinking about the game the way a stranger with a geological background and no particular interest in lottery games would think about it. They were not thinking about it as a geostatistician would, as an incomplete data problem, a surface-to-depth inference challenge. The flaw existed because the people who built the system could not see outside of the assumptions they had built it with. That, Srivastava said, was worth thinking about. Not just for lottery designers, for anyone who builds a system. The crack in any structure is usually invisible to the people who built it, because the assumptions that produce the crack are the same assumptions that guided the building. You need someone from outside, someone who doesn't share your assumptions, someone who looks at your carefully designed decorative numbers and asks a question that never occurred to you. What if these mean something? In the years since the Wired article brought Srivastava's story to international attention, a peculiar secondary conversation has developed around the case. Not about the lottery, about honesty. In study after study, behavioral economics research, ethics experiments, public surveys, the question of what people would do if they found an exploitable flaw in a system produces a consistent and somewhat gloomy result. Most people say they would report it. Most people in practice do not. The researchers who study this gap between stated ethics and actual behavior have a name for it. They call it the honesty-humility deficit, the distance between who we say we are and who we are when it actually costs us something to be who we say we are. Mohan Srivastava closed that distance. He found a crack that could have made him money. Not life-changing money, but real money. Consistent money. Money that required no particular risk because the flaw was in the design itself, and not in any law he would have had to break to exploit it. Legal gray areas existed. He could have hired a lawyer. He could have structured the operation so that the ticket examination happened at the counter. No purchase necessary until selection was made. The kind of ambiguous consumer behavior that would have been almost impossible to prosecute. He didn't explore any of that. He just called them. There is no dramatic ending to this story. No arrest, no trial, no bankruptcy, no fall from grace. Mohan Srivastava did not become famous in the way that word is usually used. He became known, in certain circles, in certain rooms, among people who care about randomness and integrity and the strange places where mathematics touches daily life. He went back to work. He analyzed ore deposits. He calculated probabilities buried in the earth. He did not buy lottery tickets anymore, not because he feared the flaw still existed, but because the game had, for him, become permanently transparent. He had looked through the scratch-off coding. He could not unlook. His story has become, in the literature of lottery security and behavioral economics, something of a clean case. A case where the expected ending didn't happen, where the man with the knowledge did not become the man with the money, where the story ends not with a collapse, but with a phone call and a letter and a game pulled from the shelves. In a genre full of ruin, his story ends with the system working. A man found something broken. He told someone. They fixed it. That's the whole story. And in some ways, that's the rarest story of all.